Hi guys, let's start a new chapter. It's called quadratic equations. So we've done some part of quadratic equations in terms of what it looks like in class 8 as class 9 as well, where we did factorization. Let's look at the basics that we already know. Quadratic equation is an equation with one variable only. The highest power of it is 2, and the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, where x is the variable and a, b, c are the uh, constants. There are certain conditions for it to be called a quadratic equation. A, b and c have to be real numbers. Obviously not imaginary but real number. And most important condition, a cannot be 0. Why can't a be 0? Because if a was 0, then this equation would get converted to bx plus c is equal to 0, where the highest power is 1, whereas the condition is the highest power has to be 2. So a cannot be 0 and a, b, c are real numbers. We've already done how to factorize quadratic expressions, the difference between expression and equation. There has to be a left hand side and right hand side in an equation. So this is an expression that I have put here. We've learned how to factorize it by splitting it into the middle term. I need to find factors of 6, the sum of which should be 5. So this is 3 into 2. So x squared plus 2x plus 3x plus 6. Group it like this and I get x times x plus 2 plus 3 times x plus 2, which is x plus 2 times x plus 3. This is what we've done in class 8 as well as class 9, factorizing, just quickly revising it. So we've done factorizing by splitting the middle term, and solution and root. So solution and root would be whatever is the equation. So in case the equation was x squared plus 5x plus 6 is equal to 0, which means this is equal to 0, which means x plus 2 is equal to 0, or x plus 3 is equal to 0, which means x is equal to minus 2, or x is equal to negative 3. So these negative 2 and negative 3 are the roots, also called solution of this quadratic equation. Good. Let's look at one more factorization before I move on. This time I have to find factors of 2 into 6, which is 12, the sum of which should be negative 7. So this would be negative 3 multiplied with negative 4. That's 2x squared minus 4x minus 3x plus 6. That's 2x times x minus 2 minus 3 times x minus 2, which means x minus 2 and 2x minus 3. Done. So quickly revising what we've done, the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. A, b, c belong to real numbers and a is not equal to 0. Let's look at some questions from your first exercise and let's see what we have. So exercise 5a1, it says find which of the following equations are quadratic. So I'll have to basically open this equation and see if it can be written in the form ax squared plus bx plus c is equal to 0. So if I open this, this becomes 9x squared plus 1, this is a squared plus b squared minus 2 into a into b, and if I open this, this becomes 5x plus 40. So this is 9x squared minus 6x minus 5x. If I take this on one side, this is plus 1 minus 40 is equal to 0. So this is 9x squared minus 11x minus 39 is equal to 0. Since this is in the form ax squared plus bx plus c is equal to 0 and a is not equal to 0, a, b, c belong to a real number. Therefore, 3x minus 1 whole square is equal to 5 times x plus 8 is a quadratic equation. Very simple. You will never get a question like this in your exam. But anyway, let's try and compare this and see what would be the value of a, b and c. So comparing with ax squared plus bx plus c is equal to 0, we get a is equal to 9, B is equal to negative 11, and C is equal to negative 39. Right? Just identifying what's the value of A, B, and C in this particular question. Let's look at the next one. The next one is figure out whether this is a quadratic equation or not. Again, we'll have to multiply this and see if we can put it in the form ax squared plus bx plus c. So this would be 3x squared plus x minus 12x minus 4. 3x squared plus x minus 12x minus 4 is equal to 3x squared plus 6x minus x minus 2. 3x squared plus 6x minus x minus 2. 3x squared and 3x squared gets cancelled. So this is negative 11x minus 4 is equal to 5x minus 2. Let's take everything on one side. So this is 5x plus 11x minus 2 plus 4 is equal to 0. Taken it on this side. I've taken negative 4 on this side. 5x plus 11x minus 2 plus 4 is equal to 0, which means 16x minus 2 is equal to 0. Since this is not in the form of ax squared plus bx plus c is equal to 0, therefore x minus 4 times 3x plus 1 is equal to 3x minus 1 times x plus 2 is not a quadratic equation. Very simple. Let's look at the next question. Question 2, part 1. It says, is x is equal to negative 3? Not part 1, part 2, sorry. X is equal to negative 3, a solution of the equation 2x squared minus 7x plus 9 is equal to 0. So if it is a solution, then it should match, left hand side should match with right hand side. So put x is equal to negative 3 in left hand side. So this is 2 times negative 3 whole square minus 7 times negative 3 plus 9. This is 2 into 9 plus 7 into 3 plus 9. This is 2 into 9 is 18. 7 into 3 is 21 plus 9. So this is 30 plus 18, 48, which is not equal to RHS, since LHS is not equal to RHS. Therefore, x is equal to minus 3 is not a solution. Some people also call the solution as root, so these are interchangeable words. Let's look at the last question of this exercise and see what we have. So question number 4, it says 2 by 3 and 1 are solutions of the equation mx squared plus nx plus 6 is equal to 0. Find value of m and n. So let's substitute value of x as 2 by 3 and x as 1 and see what value we get. So let's put x is equal to 1 first, that will be the simple one. Put x is equal to 1 in mx squared plus nx plus 6 is equal to 0. What we get is m times 1 square plus n times 1 plus 6 is equal to 0, which means m plus n plus 6 is equal to 0. That's our equation 1. Next, let's put m is equal to 2 by let's put x is equal to 2 by 3. So put x is equal to 2 by 3 in given equation, and what we get is m times 2 by 3 whole square plus n times 2 by 3 plus 6 is equal to 0. So this is 4 upon 9m plus 2 upon 3n plus 6 is equal to 0. Let's take the LCM. LCM of this would be 9. So this is 4m plus into 3. So that's 6n plus, that's 6 into 9. That's 54 is equal to 0. Let's cross multiply. So what I have here is 4m plus 6n plus 54 is equal to 0. I notice all these elements have 2 in common. Let's divide this by 2. So what I get is 2m plus 3n plus 27 is equal to 0. And this is our second equation. Now we'll solve these two equations simultaneously and see what we get. So point number 8, equation number 1 multiplied with 2, and what we get is 2m plus 2n plus 12 is equal to 0. The equation 2 is 2m plus 3n plus 27 is equal to 0. Let's subtract negative, 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 and what I have is 2n minus 3n, that's negative n, 12 minus 27, that's negative 15, is equal to 0, which means n is equal to negative 15, which means n is equal to negative 15. So we've got the value of n. Let's put n is equal to negative 15 in equation 1, and what we get is m minus 15 plus 6 is equal to 0, which is m minus 9 is equal to 0, m is equal to 9. They want the value of m and n. Let's write the answer in the solution set form, 9, negative 15. That's the final answer. That was a short exercise that finishes this video and the exercise for me. 2 questions as homework for you, question number 3 and question number 5. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.